Welcome everyone to Protastructure 2022 presentation, and we are going to be resolving and correcting 23 errors, as you can see right there. So there are 23 errors in this model. So I want to be taking us through how we can resolve all of these errors. And again, towards the end of this video, I will explain an additional error called Sparse Solvers error, and I will explain why we do have that Sparse Solvers error in our model in Protastructure. And so stay tuned, stay connected, stay throughout the presentation so that you have a full understanding on how to resolve any error at all that you have in your model in Protastructure. As we are going to resolve all of these errors, these are total numbers of 23 errors in this model. We are resolving all. Okay, and so I'm still freezing. Do not forget to like the presentation. Don't forget to also subscribe, also share the presentation. I will be closing this right away, just like this. Okay, so here is our model. In the last presentations, using this model to explain how you can anchor a beam, some persons were asking me some questions that I did not show what I did before and after. Okay, so I will be throwing more light on that, on what I did before and after. Okay, so before we should go into the error corrections, I will now have to let me navigate to the story one right there. I want to show you what I did before and after. Okay, so I will just have to navigate to the plan view of this story one. Okay, just like this. So I want to be doing a simple grid lines. Okay, again, so I'll come to model and pick orthogonal axis generator, and then I'll pick this first point. So once I pick that point in this, now I will just need to have 2 meters here, 2 meters by 2 meters, or 2 meters by 2 meters. Okay, all right, so I can just proceed to get this to be times 1. Okay, 1. I'll do comma right there, and then I'll have 3 meters, comma again, and I'll have 3 meters as well. Okay, just like this. Click on it. Okay, so I'll have something of this kind. Okay, so what I did before or after is this. Originally, you may have a wall, so you have to select a wall. So in the wall property dialog, you will have to set your wall thickness and as well as the eccentricity of the wall for your lift or elevator shaft. So at first, you will first of all have a wall connecting just like this. Okay, so I will close this so that I navigate to the 3D to show you what this is and how this looks. So you have a wall that is like this. Now there is no column in this, and then you want to anchor your beam to this wall. Normally we only have to just select beam icon right there. So in the beam dialog, you set your beams, okay, 250 by 500 depth, depends. Okay, you anchor it from this point maybe to this other point. Okay, so once you have done placing this, you can see that this beam is connected directly to the wall. So this is what I was saying, that it is wrong. Don't connect your beam directly to the wall like this. Maybe there are other structural members in this site, like the columns. Okay, let me pick columns and drop one columns here so that this beam will not be a cantilever beam. Okay, so I will pick a column here to drop a columns right there. So all right, so I'm having some warning. The column section area is this. Okay, it is because it's not satisfied. It is because I'm using a US code of practice. That's why I'm having this. Okay, so there's no problem with that. We'll correct that. So if I'm having something of this kind, you can see that this column, this beam is anchored to this wall directly, at this my left hand, and then anchor to this column at this my right hand. Okay, so you are not supposed to anchor your beam to the wall directly like this, because the load from the slab goes to the beams, and then from the beam it goes to the reinforced concrete column. So likewise, as you anchor it, some part of the load also goes to the wall, and the wall is very weak or low in resisting axial load, very low in resisting axial load. Okay, so it doesn't have that enough strength to resist an axial load that is coming from the beam. Okay, so that is why I said placing it like this is wrong. So I have to now correct this. Delete this beam, select this column, right click. You can use the property of this column, or you can pick a columns from the from the column ROC member panel. So you have to fix a column here like this. You have to fix a column here like this, and then now you can place the beam, go to the beams right there, and then pick this point and this point to have your beam. So at every point of connections of your reinforced concrete beam to a wall, there should be a column to carry the beam and not the wall itself, because if you are connecting it to the wall directly after your analysis and result, you know that the wall is dead. The wall will be dead, not even failed, it will be dead. Like, you will struggle to make it past analysis, most especially when you are designing an high-rise structure. I've experienced that. Okay, so I'm talking out of experience and not out of statistics. So you are supposed to have a columns like this at four corner of your lift successfully, just like this. Okay, so that if there's any beam that is coming, it anchors to that. So if you are, maybe you happen to have a reinforced concrete beam connecting to the center of this wall, you have to remove this wall first, create a grid length and establish a column there, so that there will be a connection from your beams to the columns. Okay, before we now place wall right there. So this is what I was trying to explain, which I believe most of us understood in the previous lesson, but some of us did not. All right, so let's go into the business of the day. Our time is fast spent. I have to delete all of this, okay, so that this will not give me an additional error that will be more than 23, just as we want to resolve. Okay, so I will have to get rid right of that. Sorry, that's not load. I'm deleting the whole of that structure right there. Okay, so now we are to look at how to resolve errors, 23 errors in today's presentations. Protastructure 2022. Mind you, we have a ongoing advanced training program. You can join us to the link. There's a Telegram link in the description of the video. There's also a WhatsApp link there. So if you want to join and you want to be trained so that you become pro in the use of Protastructure for reinforced concrete design as well for steel structure design, join this class, and then you will be trained from A to Z, like all of the structure including drawings, okay, successfully. So I want to be saving this project right away before we proceed. Okay, I will navigate to the analysis provisions right there, and then click on the building analysis right there. So let's get back to the analysis. Check building model right there, click on start, and then these are the errors generating over here. So once you have an error like this is number of error 23, what you do is you click on the load log to editor, editor. So you click on these provisions, and then now this is a notepad explaining the the errors that you're having. Okay, so the first error we're having here is a overlapping slab check. Okay, so there is an overlapping slab check. You have the FX2, FX2, FF3. Okay, so these are the foundation slab. Okay, foundation slab that I provided to use for my foundation design. Okay, of the lift wall. Okay, so the same thing applicable here. So we are going to be solving it step by step. So at once you have to remove this. Okay, you have to remove this to get rid of that error. So you click on the closed. All right, so after which close this. So how do we remove the foundations? You turn the structure this way. So this is where the problem is, this place. All right, or you can also navigate to the storage 0 right there. Click on this and navigate to the plan view. All right, so you have this slab here, so you can see FF2. So here there is an overlap. Okay, so you just have to select one, hold the control key, select the rest of these slabs right there, all these ones, okay, and then delete them just like this, get them off just like this. So we have resolved that particular error. If you get back, save the project first. Each time you resolve an error, you have to save the project first and then get back to the analysis again. So at this point, go back to the tab analysis, building model check, start it again. Let's see the number of error that is left. So now we are having only 3 errors. We have resolved, out of 23, we have resolved 20 errors for removing that. So you can see that we have only 3 errors left in the model. So let's check the load log to editor. Let's see these errors, what they are. Now story 3 slab, this beam, they are overlapping. Okay, at story 3 they say slab, 3x2 and beam, this is overlapping. Okay, so let's minimize this. All right, and then you can now close this and close this. Now we get to story 3 right there. So at this story 3 they say slab and beams is overlapping, which is here. See this 3x2 and then beam, this is overlapping. So this beam is overlapping this slab. That is what the program is telling you. So you have to actually learn to listen to and understand what the program is actually saying. So you can see slab 3x2 and beam 3b21, okay, overlapping. So it is slab 3x2 and then beam 3b21, this one. So we have to remove this beam, delete this beam right there. Just like this, we have resolved that error. Because this error, some of these errors may terminate the analysis halfway. Okay, so you have to be very, very careful. All right, so after we save the project again, for resolving that error, let's check the log again to see the next error. This one is being resolved now. Come down. Okay, so we are having story 3 beam 3b3 and beam 3b3 have repeated levels. At story 3 we have a beam that has a repeated level at story 3. Okay, so you have to resolve this. Okay, also at story 4 we have also a beam that has a repeated levels. So we have a kind of a double leveling. So minimize this, and at story 3 let's come to this place and check. You notice that this beam has a repeated levels. You see this one and this one, these 2 beams. So since they have a repeated level, what you need to do is to delete the first one. Delete the first one. Navigate to the 3D so that you really see what is happening there. At story 3, where our cursor is, where our grid line is. So the beam that is having a repeated level has been removed successfully. So if you check here, we are only having only 3b3. Okay, so now you can see what is happening right there. So the next thing we will look at, they say at story 4. So navigate to story 4 right there, and then if you check here, there is also beams. You can see this beam is having repeated level at story 4. Now you notice that this beam is at story 4. You have to actually delete that beam, okay, or you remove this one. Okay, so what you need to do is just click on delete to get rid of that beam, this one. So you can see now this beam and this one are not longer there. You can see, so they are being removed. So now you have to place it back. So select this one, right click and click on each property, and then connect this to this again, and then you have this. So this have resolved that error, or correct that error successfully. Okay, so now to place this one back, you have to navigate to story 3 right there, and then pick any of these beams, right click on each property, and then use it to place this back just like this. All right, so close this property right away. Mind you, this is an American code, okay, ACI code that I use in this model. Okay, so now click on the save, and then we'll go back to check if we still have error in this model. So you click in this provisions, building analysis, and then you come over to analysis right there, after which click on the building model check right there. So click on start. So let's check how many errors that is left now in this model. All right, so here we go. The number of error is 0. So we have resolved the 22 errors that were found in this structure. So now the structure is set for analysis and design. So I will be taking you to analysis and design now, and then you see some warnings during analysis, and I will explain those warnings to us successfully. Now there's a difference between a warning and an error, so we should try to differentiate between these two. All right, let's try to differentiate between these two, warning and error. So whenever we have a warning in a structure, simply means you can carry out your analysis and as well as design of your structure successfully. Just that there is a warning that you need to take note of. Okay, but when you have an error, it's mostly terminate analysis. So let's close this. All right, and then we get to let's get to also close this as well, or we can get to pre-analysis. Now if you check very well, you can see the reinforcement stick grade XD40, just as I've said that I use the ACI code. That is why you're having all of this. So if you want to edit all of this, you can edit this, okay, successfully, which is the materials, but we will be actually working based on the default materials here successfully. So I will just click on the close, and then I will take us to the settings right there, and then I'll show you something right there. Okay, so I click on this setting tab. Okay, so here is the options dialog. Okay, so you can see over here the code used here. Okay, it's Thailand. Okay, if you see the loading code here, it's ACI. Okay, and the state design code is ACI. The concrete design code is ACI 31840 United States. Okay, so if you click here as well, you can also make changes to this. Okay, for instance, I click in these provisions. All right, this is the wind load code used. Okay, this one. Okay, so you can also check this is for the United Kingdom, right? So United States wind load guide. Okay, so you can choose if you apply the wind load to the structure as well. We are applying the wind load, so you have to select the ACI code for wind load, which is this one. Okay, so click on the picked option to pick that successfully. So this will change. Okay, it has changed from Thailand to United States. So this is how you make changes in your codes. All right, so over here as well, you have the earthquake code is also Thailand, seismic loading standard for building design in Thailand. Okay, so you can change this as well. For your earthquake code, you have to check through this. If you will actually see United States, you can see IBC United States, this one international building code, you can select that for your earthquake. Pick that. Okay, so now we have make our code of practice Asia, United States, everything United States there. Now we are good to go. If you want to apply your seismic, you can go and activate it. Okay, which we are not going to cover that, but if you actually enroll in the advanced training, the master training program that is ongoing, most of these things will be explained to you in that training successfully. Click on the OK options, right, and then you click on the yes options to accept that. Okay, after which you have to save your project. After saving your project, we are now good to go into analysis and design. But before you go into analysis and design, you have to also set some parameters successfully, like the beams. You need to set the minimum and the maximum reinforcement. Okay, for the beams you have to set the minimum and the maximum rebar. So it's been selected successfully. You can see this is the minimum and this one is the maximum. You have to check all of this to make sure that they are in order, so that you will not have unnecessary failure. Okay, so I just want us to understand this. Okay, let's go to analysis provisions. Click on building analysis. This time around we'll go to the analysis tab, and then we will click on the building analysis right there. Okay, so this is batch design options. Okay, all right, so if you want the program to actually analyze and as well design the project for you, you need to check all of this. It's going to analyze and design the model successfully. But if you leave these places unchecked, the program will only analyze, and it is not going to design. So the design, you are going to do it on your own using other methods, which I'm going to be showing you. So I'll only check the team members, because there are team members in this structure. I'll only check the team members so that the program will actually analyze and design the team members, while every other members I will show you how to carry out that successfully. So click on the building analysis right there. Then let's give the program some seconds to actually carry out the process successfully. So building analysis is completed, and you can see summary report of all the important check in this model. This is summary report. Check over your building analysis completed successfully. So throughout the process there is no error. All right, so after the analysis completed, you see this message coming up. So this message said in the direction 1, stiffness irregularity does not exist in the direction 1. Okay, stiffness in the stiffness irregularity does not exist, but in the direction 2, there is a warning stiffness irregularity encountered in the structure. Now, when you are seeing most of this warning, is because of some of your model, some of your structural members, the way you model them and how you incline them. So as you can see in the structure that I have some inclined columns, right? Columns that are being inclined. So that is why you see most of this successfully. So this is just a warning trying to tell you something of that kind is in your model. And so you have to take note of it and how it's being reinforced even at the construction site successfully, so as to avoid maybe unnecessary maybe failure. Okay, so these are warnings based on the the pattern of your model and the orientations of your reinforced concrete members in your structure. Okay, which in the structure right there you can see how I inclined my columns. Okay, not one column, not also two columns, which is bringing up most of this warning right there. This is a warning and not an error. Okay, so now you see the effective mass ratio satisfy the code requirement. Okay, so if we check here, you can see relative story draft in both direction 1 and 2 are okay. And then the second order effects are encountered using code-based slenderness method. Okay, and also if you check very well, the program also check for an overturning, okay, in the direction 1 and direction 2. Now when you are seeing direction 1 and direction 2, we asking question, why are we having direction 1 and direction 2? Direction 1 and direction 2 has to do with the x and the y direction successfully. All right, so that is very important when most of this calculation embedded in the program is being processing. They consider these directions and then they check, and then for the overturning over here, I see it is adequate. Okay, it's also overturning in the direction 2 is adequate. All right, so that is just a summary of the analysis result. So you just have to click on the close options, and then see over here, video analysis completed successfully, and then click on the close over here, or you can go to the post processing. If you go to the post processing, you can check the analytical model, which we may not honestly check that, but we will look at the reinforced concrete columns and the beams, okay, to make sure all has been actually designed successfully. So if I click on the close options right there, and then as I will navigate to the review, right there, if I check in this visual interrogations and I click on the design statute, I pick that point, you will notice that you see green simply means okay, this which I've told you that the reinforced concrete members have not been designed. What was designed in this structure is the steel member. You can see all the steel members showed green right here. Okay, simply means the steel members have been designed and they have passed the analysis as well as design. Okay, while this member that is showing white, you can see the key here, said not design. Okay, so I'm first of all showing you this so that after design you will see that yes, all of this has been designed successfully. So let's get rid of these provisions and then click on this provisions to get that off, just like this. Save this project first. Okay, don't forget to be saving your project in the process of working on your model. All right, so you have to now navigate to the analysis tab. Now click on this building analysis, go to the post processing. You can also pass through this other way, structural tree, to get to these provisions. All right, so now we want to be checking the columns to make sure they are designed successfully, as well as the reinforced concrete beam. So what I will do is I will click on the column right there. So I click on the column / wall design, and I have my column reinforcement designs dialog. So I'll have to expand it so you can see all of the column now is designed. Yeah, so all these ones that you are seeing that is having 2450 are not columns, rather they are the walls. Okay, so you can see 1W1, 2W2, 3W1. Okay, so all of that, so is the wall. So you have to use this column design batch mode. Click on that. So once you click on that, you have this dialog. Select this last options, reselect all bars, and then click on calculate. So you give the program just some seconds, it is going to calculate and then be able to provide rebars for all of these columns. If there's any section that is insufficient, it will actually identify it as a failed section, which can later be edited successfully. So let's just give the program some few seconds to carry out the design successfully. So it's going to design up to 114 members, you can see here, okay, for all the stories successfully. So design is okay, design is done. Now click on the closed to have it result just like this. So you can see the presentations of the ACI code, all right, the links, the rebars, all right. So this is how it's being presented successfully. As you can see over here, you can check the U ratio. The U ratio are even less and lesser. Okay, now why we are having this U ratio very less than 1, very much less than 1, is because we did not officially apply wind load. We did not also officially apply earthquake load on this structure. Assuming we officially apply these two loads, you could have seen that even the sections may not necessarily be sufficient. Okay, but this is for the sake of presentations of today. So if you want to know more about this design using Protastructure in any of these codes, just join our ongoing master class, okay, and then we will train you from A to Z. Okay, so this as Sparse design, you can check the walls as also Sparse design successfully, all of the wall. So if you select any of these now, you want to see the rebar, click on this interactive design. So once you click on this interactive design, it's going to take us to another dialog where we will be able to actually check and see the numbers of reinforcement generated in this. So if I click on this these provisions now, it will take us and show us the total number of rebars in this wall successfully, just like this. Okay, and then you can also see that it is 4 dB 12. Okay, so it's a 12 diameter bars that is being used in this wall successfully. Click on the OK options. So that is all that I can show us here. So we close this dialog. So let us look at the beams. So if you check over here too, you can see the columns being designed. Check a green check right there. Okay, so we can also look at the beams to make sure they are all designed as well. So clicking on the beams reinforce design, you have this dialog. Also use the bash mode and then reselect bar, click on calculate, click on yes options, and then it is going to calculate and then design all the beams successfully. So you have to click on this close option so to have all the beams designed just like this. Okay, all right, so having done that, you just have to close this dialog, and then now you can export this structure to these two programs successfully. All right, if you can want to check this structure using ETAP, you can just click on the export and the file will be created in the program directory where you can use to access this software called ETAP, okay, as well as SAP 2000 successfully. All right, so I will be clicking on the close options right there. All right, so at this point we will be looking at the structure, but by then let's save this project successfully just like this, and then get to you can get to the review. All right, and then come to visual interrogations, click right there, so you can see the structure now. All of the beams and the columns have been designed. Okay, so it's now remaining the slab. We have not actually designed the slab by generating reinforcement for the slab. We have not done that. Okay, so all of this has been done stages by stages successfully. So that is what I intended showing you. The next thing I want to show you right now is the sparse solver error. So whenever you design a structure and you have a sparse solver error, I promise to explain this to you. It simply means you have a member that is not properly connected to the node point. Okay, and so the calculation within that node area is confusing in the system. Okay, so what you just do is just to remove the degree of freedom. Only the degree of freedom simply means you have removed the sparse solver. Okay, so how do you remove sparse solver in that case? And again, sparse solver error also come up when you have most of these inclined members. Okay, like the slab, you try to manage to create a slab in form of a stairway. That is why most of the time you see our design, we don't provide that slab, okay, that look like a stairway, okay, because it causes that sparse solvers error. So you just have to neglect that in your design. All right, so once you have the sparse solver error, what you just need to do is you have to navigate to the analysis tab and then click on the building analysis, and then come to the model options, come to this settings. So see this, use sparse solver for building analysis. All right, so when you are using sparse solver for your building analysis, simply means there is a degree of freedom that is existing in the building model. Okay, but once you remove it, it simply means you have removed that degree of freedom. But for a manual calculation, we know what is degree of freedom. So I believe strongly. Okay, so once you have that error, come over here and uncheck this. Then go back and run analysis again. The structure will be analyzed successfully. But although there will be a warning that you have removed the degree of freedom. So that is Sparse Solvers error and how to rectify or correct it successfully. I believe strongly that you have learned one or two things in these presentations. Don't forget to like the presentation, please. Don't also forget to subscribe to this channel's soft phrasing, and we will bring into you more advanced lessons of this kind. We are bringing the lesson to a stop here, and then we will see in the next presentation. So stay tuned, stay connected. And also I want to remind you, if you want to be pro in structures, Protastructure, reinforced concrete design, and as well as steel design, try our masterclass. Okay, try our masterclass, and then we will teach you from A to Z, including drawings and presentations successfully. Okay, so stay tuned, stay connected, and stay safe. See you in the next presentation, and bye for now.